Hi dear students and friends. So myself Manjunath PC, working as Senior Assistant Professor in the Department of Computer Science and Engineering at Reva Institute of Technology and Management, Yelahanka, Bangalore. So in continuation to with my previous sessions, so I will like to continue on the concept of functions, arrays and strings. So before I proceed to today's session, so let us see what we discussed in the previous session. So in the last sessions we have seen like the two-dimensional arrays. We have revisited the concept of two-dimensional arrays in the last session, followed by a simple programs on a two-dimensional arrays. Then we have seen a program to read and print a matrix, how to read a matrix and how to print a matrix also we have learned in a C program how it can be done. So then we have seen the program to compute transpose of a matrix, and also we have seen the two concepts by which the array elements are stored in the memory. So either it could be in row major order or it could be in column major order. So basically the C language supports the row major ordering of the elements, the way how the elements get stored in the memory. And later we have seen even a program to read a matrix in row major order and also a program to read a matrix in column major order. In the today's session, so we will see the one major applications of the matrices, that is the matrix addition. So along with that we see an example of matrix addition and we see a C program to compute sum of two matrices, and followed by we will see the matrix multiplication. So an example of matrix multiplication, then followed by again we revisit the row major and the column major orders, because as per the lab program we have to read the matrix elements in row major order and also in the column major order. We will see that in the respective program when we see. And then we will see the matrix multiplication algorithms, how the matrix multiplication has to be done. The followed by, so we will see a C program that computes the product of two matrices. Now, so when you come to the addition of two matrices, so that is one of the major application, so which is used in various domains. So in case of matrix addition, so we must note that if A and B are matrices of order m cross n, so then the sum of A and B denoted by A plus B is a matrix obtained by adding the corresponding elements of A and B. Here note that the A and B matrices should be of same order m cross n. If A is a 2 cross 3 matrix, B also must be 2 cross 3 matrix. So if there is a misorder, if A and is of different order, B is of different order, then we may not compute the A plus B, that is the sum of two matrices. Here we have to note that the corresponding elements of A and B so will be added there. Because of these corresponding elements, so we say that the order of two matrices so which we are going to add should be of same order, that is m cross n, where here m represent the rows of the matrix and n represent the column of the matrix. Let's see one example. So now, so here you can see like, so the first matrix A, so this is a 3 cross 3 matrix, B is also of 3 cross 3 matrix. As a consequence, result also we get in 3 cross 3 matrix. So now, so here we can see like, if I am assuming this as the matrix A and this as matrix B, then this is a 3 cross 3 matrix. This is 0th row, first row and the second row. Similarly, 0th column, first column and the second column. So A of 0 0 element is 2 and B of 0 0 element is 1. So when I add up these two elements, 2 plus 1 is 3 will be the value for some matrix. If I am calling this as a matrix C, then C of 0 0 will be the sum of A of 0 0 and B of 0 0. Similarly, so this element 5 in the matrix A, so the index of this particular element in the matrix A is 0th row and the first column from the program point of view, that is A of 0 1 is the element of so the matrix A, that is 5 here, and similarly B of 0th row and first column B of 0 1 is 4. When I add these two things we get the element as 9. That will be the value for the 0th row first column element of the matrix C here. So that's how, so the all the elements of the matrix A correspondingly added with the elements of matrix B, and finally we get the result as the resultant matrix C, which is the sum of the matrix A as well as the matrix B. Now if you want to write a program so to compute the addition of two matrices. Now, so here the basic thing what is required is, first we have to read matrix A, so this is the first thing, and we have to see the matrix B and we have to perform the addition and we have to print the result as the matrix C here. So here I have taken the matrix square matrices, but not mandate that the matrices should be square matrices when I am performing the addition. The only constraint on the matrix addition is the both matrices A and B should be of same order. Say for example, if I take the matrix A as something like a 2 cross 3 matrix and matrix B must be of 2 cross 3 only. When I perform the addition here, I get a matrix C which is also of 2 cross 3. So here 2 rows and 3 columns I am mentioning in the example. Now say for example the elements of matrix A are, so there are 2 rows, right? Let me consider 1, 2, 3. The elements of the first 0th row as per the program point of view, and from the first row elements here I assume like something like 5, so 2 and 0, and plus this is the matrix A. And similarly if I take another matrix B, say for example it is so elements are 1, 2 and 2, and the 2 rows, and the so first row elements and the second row elements, let me take it as something like 0, 6 and 7. So this is the matrix B. This is also of same order, 2 rows and 3 columns, and this is also of same order, 2 rows and 3 columns. When I perform the addition, the result what we get is this is also should be of 2 rows and 3 columns, right? This is the matrix C, let me call. Now, so here what I do now is, this is 0th row, this is 0th column, so this is first column and this is the second column. So similarly this is 0th column, so this is the first column and this is the second column. So what I do now is 1 plus 1 I get 2 here, 2 plus 2 I get 4 here. Similarly 3 plus 2 I get the value 5 here. So 5 plus 0 I get the value 5 here. 2 plus 6 I get the value 8 here. Similarly 0 plus 7 I get the value 7 here. So we can note here like, so each corresponding element, if this is 0th row and 0th column element of A, so then I will take 0th row and the first column 0th column element of matrix B, and we get the 0th row and so 0th column element of matrix C. Similarly, correspondingly we add up all the elements and finally we will be getting the resultant matrix. So here we can note that, so here matrix A and matrix B are not square matrices, right? In the example, so we have taken square matrix, and here we are taking a matrix which is not a square matrix. The only constraint here is the order of A and B should be of same order. So order should be same, only then we can compute the sum matrix there. So if you look into the program of computing the addition of 2 matrices here, so now, so what is the first thing we require is we have to read the matrix A and then we have to read the matrix B elements. So here this is the declarations that we require in coding this particular so addition of 2 matrices. Now here R and C are the row and the column values of the matrix, and A of 10 10. So here I am mentioning the maximum size of the matrix can be a 10 cross 10, 10 rows and 10 columns it may have. This is the matrix A. Similarly I have to do the declarations for a matrix B also, and to store the result I am calling the matrix as sum. So sum of 10 10 represent the 10 cross 10 matrix. So here if I am reading a 2 cross 3 matrix, B also should be of same order and some matrix will be also of a same order. Since I will be in the looping construct when I am using the so 2-dimension arrays or even the arrays, so I will be using the loop iterators. I require 2 loop iterates here, I and j. First we look at the printf statement, enter the number of rows, and here so since we are mentioning the size of the row as a 10, the row size should be between 1 to 10 here. So I will be reading with this scanf statement the row size of the matrix A. Similarly, I ask for the so column size of the matrix. So here this also should be of 1 to 10 only, right? Because we are mentioning the size as a 10 here in both A matrix and the B matrix. So here scanf %d %c. So here column value is read and the column size is read and the row size is read. Now in continuation of this program, first we are supposed to read the elements of matrix A, then you have to read elements of matrix B, and then you have to compute the sum. Now, so in order to code the elements of matrix A, we use the looping constructor. This we have seen in the previous session how to read a matrix. The same logic we can apply here for reading the matrix A. Now, if you look at this particular code segment, so enter the elements of matrix 1. I am printing a message here to get the elements of matrix 1. Since we have R rows in the matrix A and C columns, right? So I is equal to 0, I less than R, I plus plus. Now, for each row, I read the for each particular row, I read each of the column elements one by one. So here, so 0th column, j less than c, j plus. So j is equal to 0, j less than c, j plus plus. Here I am asked here enter the element a %d, I comma j. So here I will be asking like a of 0 0 after j incremented, I will ask for a of 0 1, a of 0 2 and so on up to the last column, last but one column, because we start the index from here 0. Now scanf percentage d ampersand a of ij. This particular way of reading a matrix using the looping constructs we have seen in the previous session only. With the same logic, so in this particular code I will be reading the elements of matrix A. Similarly, so we are supposed to read the elements of matrix B also. So here we say the statements almost same. So but only thing is here I am reading the value to matrix A, but here I will be reading the values to matrix B here. Here I request a message print of enter elements of matrix 2. So here I have taken the elements of matrix 1. Now I will be taking the elements of matrix 2 here. So here also same looping construct I use here. I is equal to 0, I less than R, I plus plus, j is equal to 0, j less than C, j plus plus. I will be asking for the b of 0 0, b of 0 1, b of 0 2, likewise all the elements of the matrix. So here in the scanf statement percentage d ampersand b of ij. So when I use the ampersand b of ij, I am reading the element into the B matrix. When I am using here ampersand of a of ij, I will be reading the element into the matrix A. So that's how the difference, almost the same, everything completely it is same, reading of matrix A as well as reading of matrix B, but only thing is here I am reading into the A matrix, whereas here I am reading into the B matrix. So this is how you can see, like again, so here the condition is I less than R, here also condition is j less than C, and the same conditions I use here, I less than R and j less than C, because when you are performing the addition of two matrices, the order of the two matrices should be same here. So the R and C, the row size and the column size remains same for both matrix A and matrix B here. Now after reading the elements of matrix A and matrix B, we supposed to perform the summation of two matrices. Now, so here is the code, so which performs the computation of addition of two matrices here. This is the important statements of this particular program. So where the logic of performing the addition of two matrices lies within this particular code segment. For I is equal to 0, I less than R, I plus plus, j is equal to 0, j less than C, j plus plus, a of ij refers to if I value and j values are 0, a of ij means a of 0 0, 0th element of the 0th row, 0th column element of the matrix A. Similarly, b of ij refers to if I and j values are 0, b of 0 0, that is 0th row, 0th column element of B matrix. When I add these two things, sum I should store in 0th row and 0th column of sum matrix. So here sum of ij I will be taking it as a of ij plus b of ij. So this way I will be computing in correspondingly every element of matrix A I will take, and I add that with every element of matrix B, and then with this particular statement here every element of matrix A I am reading, and here I read every elements of matrix B, and after performing the sum I store the result in the corresponding location in the sum matrix. So here sum of 0 0 will be holding the value of a of 0 0 plus b of 0 0. Similarly, sum of 0 1 will be holding a of 0 1 plus b of 0 1, and so on. Based on the row and column size, the loop will iterate corresponding. So after having computed the sum of matrices, now we are supposed to print the matrix. We know that how to print a matrix. The way how we normally print a matrix, the same way we are supposed to print the sum matrix here, right? So to print the sum matrix, so I display a message here, sum of true matrices is. So and then I is equal to 0, I less than R, I plus plus. This is the row. And then before printing the new row elements, go to the new line. This is the way how the matrix has to be printed. So normally the matrix should be printed in the matrix form only. If you just print the elements of the matrix in a serial order, it will be like a list of elements. We don't visualize that as the matrix element. So whenever we are printing the matrix element, so we must make a note that we must print them in the form of the matrix only, and that's the recommended way of programming. So here so far whenever I am printing the new row elements, I take a new line and take a tab space and I start printing the elements there. So here when I is equal to 0, I will be printing the 0th row elements. When I is equal to 1, I will be printing the first row elements, and so on up to r minus 1. Fine. So since the index starts from 0 to r minus 1, the I loop will run, and similarly 0 to c minus 1, the jth loop will run here. So the j loop will run from 0 to c minus 1, where c refers to the column of the size of the columns of the matrix here. So here print of percentage d sum of ij. When I is 0, j is 0, I print the result sum of 0 0. When I is 0, j is 1, I print sum 0 1, and so on. I'll print all the elements of the matrix. After that I return 0 and I terminate the program here, right? This is the way. So how I can program, so to read a matrix A and to read a matrix B, and then printing the computing the sum of the matrices, and finally to printing the result of the sum matrix, right? So now we will see the next one more application, so that is the matrix multiplication. This is one of the major application which is used in various domains like image processing and so on. We will be using this matrix multiplication and even the matrix addition also. Now, so here, so when you are doing the matrix multiplication, this is quite different from that of matrix addition. This is not the normal multiplication what we do. So here, in case of matrix multiplication, so if you consider an example, you will get to know how exactly the matrix multiplication will be done. So this is some normal multiplication. This is quite different. So now, so here consider two matrices. So matrix A and matrix B. The order of matrix A is 2 rows and 3 columns, whereas order of matrix B is 3 rows and 2 columns. This is 3 cross 2, whereas matrix A is 2 cross 3. And here, so first we multiply the first row elements of matrix A with the first column elements of matrix B, and then we add products to get the result at the first row and first column of the answer. So that is of the resultant matrix. So we multiply row elements with the column elements to get the product. So here this is the row elements and these are the column elements of matrix B. So now I individually multiply the elements there. So 3 we multiply with the 2, and then so we get here 3 into 2. Then we multiply the second element with the, so this is 0th element, 0th row and 0th column element. This is 0th row and 0th column element of matrix B. Here it is 0th row and first column element, whereas here it is so first row and the 0th column element. So we multiply minus 2 with the minus 1. So we get minus 2 into minus 1. So that must be added up to the previous product, that is 3 into 2. So then we multiply 1 with the minus 3. So the here the sum what we get is 5. So this is the element of the new matrix, the resultant matrix A into B what we are computing here, right? So 3 multiplied with 2, minus 2 multiplied with minus 1. So 1 multiplied with minus 3, I added the products and I am getting the value there as 5. Similarly, to compute the next elements, so here, so 3 I multiply with 4, minus 2, so here 3 into 4, and then minus 2 I multiply with 3, so I get the value minus 2 into 3 there, and then so 1 I multiply with 1, so I get the value as 7 there, and that 7 will be is the element of the 0th row and the first column. Fine. So now, so the row is over, the 0th row is over from the A matrix. Now we have to take the first row of the matrix A here. So 3, so here we can select 2 cross 3 is the order of the matrix A, 3 cross 2 is the order of matrix B. So now, so next row when I take, so we multiply 0 with 2, and then we multiply 4 with minus 1, and then we multiply minus 1 with minus 3. The result what we get there is minus 1. So minus 1 will be the element, so what we get in the product matrix. Similarly, if I go for the next column of the matrix B, 0 is multiplied with 4, and then 4 is multiplied with 3, and then so minus 1 is multiplied with the 1. So as a result we get 11 there. So 11 is the answer in the product matrix here. Here we can see, observe various things here. The matrix A is of order 2 cross 3 and matrix B is of order 3 cross 2, and the result matrix what we are getting, this is of order 2 cross 2. And here you also should note that the number of columns of the matrix A should be same as number of rows of the matrix B. This is a mandate when you are doing the matrix multiplication. So here you see that number of rows of matrix A is 3 and the number of columns of matrix B is 3. Both are the same values, right? And then the resultant matrix order will be the number of rows of matrix A cross the number of columns of matrix B. So here number of rows is 2 and number of columns in matrix B is 2. So is the reason here we get 2 cross 2 as the resultant matrix. But there can be any number of rows in matrix A, any number of columns in matrix B, but only condition here is the number of columns of matrix A should be same as number of rows of the matrix B in order to perform the multiplication of two matrices A and B. So now, so look into the Notice the size of A and B and the size of the product AB here. That's what the size of A is 2 cross 3, size of B is 3 cross 2. So here number of rows of matrix A should be same as, sorry, number of columns of matrix A should be same as number of rows of the matrix B here. And the order of matrix AB what we computed here is 2 cross 2. Now, so look into another example here. So here the A is of 3 rows and 2 columns, B is of 2 rows and 4 columns, C is of 3 rows and 4 columns. So 3 is the number of rows of matrix A, 2 is the number of columns of matrix A, 2 is the number of rows of matrix B, and 4 is the number of columns of matrix B. See that number of columns of matrix A should be same as number of rows of matrix B. So is the reason here also 2 and here also it is 2. So 2 is the number of columns of matrix A and here 2 is the number of rows of matrix B. And the order, the product what we are getting there, that will be of order 3 cross 4, that is number of rows of A, so cross, so number of columns of B. Here the resultant matrix is of order 3 cross 4. So is the reason here I am declaring it as C of 3 comma 4. This is just an example. So now, so here the value, first value computed will be 22. So how exactly it is computed? The 0th row of matrix A multiplied with the 0th row of column of matrix B. So we can see like 3 into 2 plus 4 into 4. So here the value what we get is 3 into 2 plus 4 into 4 is 22. So is the reason we compute the value 22 in the resultant matrix. The next element that is computed is 29. So how we compute that? The same 0th row element multiply with the second column. I mean, so from the end user point of view, second column. From the program point of view, this is the first column. This is 0th column, first column, second column and the third column, because the index starts from 0. So when multiply 3 and 4 with 3 and 5 and add up the products, so we get the value as 29. So we'll see that. So again, so 29 is the second element what you are getting. So in the 0th row, that is 0th row and the first column element what we are getting there is a 29. So how exactly we get there is, so multiply 3 and 4 with that of 3 and 5. So 3 3s are 9, 4 5s are 20. So the answer what we get there is 29. Similarly, the next element, so we get as 45. So 3 into 7 plus 4 into 6, we are getting 45 there. Similarly, so when you compute the last element, we will be getting 35. So that is how the 0th row of the product matrix, we are getting the values there. Then after computing the 0th row elements, you have to go for computing the first row elements. When you are going for the first row elements, we should take the first row of the matrix A. This is a 0th row. Then we compute first row. So first row is multiply with each of the column. So we will be getting number of columns is same as the order, the number of columns of the B matrix. And since each row elements we are taking here, the number of rows of the resultant matrix is same as number of rows of the matrix A. So here 5 and 2, when I take the values there, so here the value 18 is computed. So 5 and 2 I will be taking the value multiplying with the 2 and 4. So I will be getting the value as 5 into 2 plus 2 into 4 as a 18. So next I will compute the value 40 as 5 into 5 and 2 elements of the matrix A get multiplied with the 3 and 5 the elements of matrix B. So that is 5 into 3 plus 2 into 5, we are getting 40 over there. Similarly, so the next element we get 47, 5 into 7 plus 2 into 6, and similarly we get 21. So next we go for the next row of the matrix A. So here 26 is computed. So that is 1 into 2 plus 6 into 4. So that is, so we get the value as 26. The next element we compute it as 33, and next element we compute it as 43, and similarly the last element we compute it as 49. So this is the way how exactly the matrix multiplication is done here. Now if you look at the logic of implementation of this matrix multiplication program, so here the I represent the rows. When I is 0, we are referring to 0th row. When I is 1, we are referring to the first row. When I is 2, we are referring to the second row. Similarly, when j is 0, we are referring to the 0th column of matrix B. When j is 1, we refer to the first column. J is 2, we are referring to the second column. When j is 3, we are referring to the third column, or from the end user point of view, that is the fourth column, right? So now each of the elements correspondingly will be computed, and we get the values in the resultant matrix. There is the product matrix there. So now if you look at the 0th row of matrix A and 0th column of matrix B, if I take 3 we multiply with the 2, 4 we multiply with the 4. So here how we can code this is, so for I is C of ij, initially I take this particular element value as a 0. So A of I, k is equal to 0 here initially. So when k value is taken as 0 there, so then A of I0 multiplied with the B of 0j. So that is j value is also 0 there. So A of 0 0, this element is A of 0 0, multiply with B of 0 0, and I add this particular product to the next element, that is A of 0 1 multiplied with B of 1 0, right. That is what the multiplication we do here, and finally we are getting the value here as 22. Now consider the situation, another example. If I have a matrix, say for example, so this is 3 cross 4. So we will be having 4 columns and we will be correspondingly having 3 rows here. And when I am taking this is matrix A, and when computing the matrix B here, the order of this matrix should be of, so same 4 cross, and here I can be of anything. So say for example 4 rows, this is 0th row, first row, second row and third row, and 2 columns. Now consider this particular element where we are supposed to compute. Now the result matrix what we get is, see 4 and 4, these values should be same when you are computing the multiplication of 2 matrices. The resultant matrix what we get, the order is 3 cross 2. So 3 rows we will be having and 2 columns, because 3 rows we have in matrix A, so here 3 rows will be in the resultant matrix C. So that is A into B what we are getting here, and 2 columns we get in the product matrix because we have 2 columns in the matrix A. Now say for example this particular value I supposed to compute, then so this 0th row elements I must multiply with this particular column element. This is 0th row 0th column, 0th row first column, 0th row second column, and this value will be 0th row third column. Similarly this element value will be like 0th row first column, and this value will be first row first column, and this value will be like second row first column, and the last value of this particular matrix is like third row and the first column. These are the 4 elements of the second column. These are the 4 elements of the 0th row, right. So when you want to compute this particular result, so the value what we get here is, basically we are going to compute here C of, if I am calling this product as a C is equal to A into B. This is 0th row, first row, second row. This is 0th row, and here we will be getting 2 columns. So this is 0th column, this is the first column. This value will be C of 0 1. How I am going to compute this particular result here? So we say here like, so C of 0th row first column, we initially take this as the value 0 here, right. So now C of 0 1 will be computed as something like the matrix A here. So first I take individual elements of this 0th row 0th column, multiply with the B element matrix, that is 0th row and first column. I will add this with, again I will take the 0th row first column element of the matrix A. So that is A of 0th row and first column. I will multiply with, so here first row first column element, fine, and then I take the next element A of 0th row and the second column element multiplied with B of second row and the first column element. Again I will take A of, I will take the next element 0th row second column multiply with B of second row and the first column. Finally I will take one more product, that is 0th row third column multiplied with B of third row and the first column, fine. What you are supposed to notice here is, so this particular index and this index, everywhere when you are doing the multiplication, that remains the same here, right. This is most important when you are coding here, right. And here always A index will be, so the row index will be 0 only, because we are taking the 0th row element, and the column index of matrix, it is always 1 only, because we are taking the first column element there. So when k is equal to 0, we compute this particular product. When k is equal to 1, we compute the second product. When k is equal to 2, we compute the third product. When k is equal to 3, we compute this particular product. Similarly, when k is equal to 4, so we compute this. Basically, since we are running from 0 here, this is first product, second product, third, 1, 2, 3, 4 and 5 products we have computed here. 0, 0, 0, 1, 1, 1, 0, 2, 2, 1. So basically here, so I have taken this particular statement again here. We take only 4 multiplications. K is equal to 0, k is equal to 1, k is equal to 2 and k is equal to 3. We don't have this particular situation now. So here when k is equal to 0, 1, 2, 3, we are doing here 4 multiplication here. So the number of multiplication we do is same as this particular value here, where 4 is the number of columns of the matrix A and which is same as number of rows of the matrix B here. The k should run from 0 to the number of the common element, that is the number of rows of matrix A is same as number of columns of matrix, number of columns of matrix A is same as number of rows of matrix B. The k should run from 0, 1, 2, 3 here, right. So here what we can code here like, so something like, so in the program statement you can see like C of ij is equal to C of I into A of I0 multiplied with B of 0j, right. So here k value must be taken as 0 plus A of I1 plus B of 1j. Similarly, with respect to this particular example what we have considered, when k becomes 2, we will become computing like A of I2, so into B of 2j. Similarly, when k value becomes 3, we compute A of I3 into B of 3j. So likewise, so based on the incrementing this particular k value as a loop iterator, we have to compute this particular product there, right. So using this particular logic, we can write the program for multiplication of 2 matrices here. So now here, so when you go for coding, you will get to know how exactly we can write the multiplication of the 2 matrices logic there. So before that, so certain observations what is supposed to do in the multiplication of 2 matrices is like, the m cross n is the matrix of A order, so order of matrix A, and p cross q is the order of matrix B if I consider, then n and p should be same there. If n and p are not same, then we cannot perform the matrix multiplication. Similarly, m and q what we get, that will be the size of the product matrix what we get, that is the product matrix finally what we are getting, it is same as number of rows of matrix A and the number of columns of matrix Q. So that is, so matrix B, that is m cross q will be the size of the matrix C, that is the product matrix what we compute there. And here we must note that if the number of columns of matrix A is not equal to number of rows of matrix B, that is if n is not equal to p, then we cannot perform the multiplication. Thus, so the product AB is not possible. So when you are doing the matrix multiplication, we should see that the number of columns of matrix A should be same as number of rows of matrix B there. So now, if you want to compute C of mq, that is the result of matrix multiplication. So here A is a matrix of order m cross n, B is a matrix of order p cross q there. So here n and p must be same, only then we perform the multiplication. Assume n and p are same there, then the resultant matrix what we get will be of order m cross q. So is the reason here C is a product matrix which is of order m cross q, and here A is a matrix of order m cross n and B is a matrix of order p cross q there. Now, so here this is the code where exactly we compute the product of 2 matrices. When I is equal to 0, j is equal to 0, we initialize C of ij value as a 0 there, right. So consider in this particular example, if I take the elements of this as 2, 1, 3 and 1, and if I take this particular column elements as something like 1, 0, 2 and 3. So let me take some values here also, 5, 2, 3, 1, and here something like 3, 1, 0, 2, 2, 0, 0, 1, something like this. This is a 3 cross 4 matrix, this is a 4 cross 2 matrix. If I want to compute the result of this particular element, right. Now, initially how the code works is, when I is equal to 0, or we start with this particular element here, when I is equal to 0, what will happen? So j also will becomes 0. When I is equal to 0, when I come to this particular loop here, so the j value becomes 0 there. So now the I will run from 0 to m, because we have here, so 0, 1, 2, 2 rows. So m is equal to 2, and then the n is equal to 4 here, p is equal to 4, q is equal to 4. This is most important here. The values n and p are same here, we can perform the matrix multiplication. Now, so here when I is equal to 0, it will run from 0 to 2 here, 0, 1 and 2, because here, so this here m value is 3 cross 4 matrix what you have taken here. When I is equal to 0, we come to the loop in the looping statement here in the program, right? So for n I is equal to 0, I will come to the j loop, j also will be 0 there. Then when I come to the j loop here, c of ij is equal to 0. So that is, initially we take here c of 0, 0 value as a 0. So means this particular value I will be taking it as a 0 initially. Then the k will run from 0 to n. Why? Because so n is the number of rows of matrix A, which is same as number of columns of matrix A, which is same as number of rows of the matrix B here. So k will run from 0, 1, 2 and 3. When k is equal to 0, what we compute there is c of ij is equal to c of ij plus a of ik into b of kj. So if I substitute the values of I and j there, what I get is, when I, j values are 0 here, so I get the equation as c of 0, 0 plus a of 0, 0 into b of 0, 0, means this particular product I will be computing. Say if I am computing here c of 0, 0 value, so I will be computing here, so a of c of 0, 0 is equal to a of 0, 0 into b of 0, 0 value I am computing. I am initializing here, initially c of 0, 0 value as a 0. Now I update the c of 0, 0 value as the product of these two values. What is a of 0, 0 value? 2 here, b of 0, 0 value is 5. 2 5s are 10, so 10 is the value what I get currently. Still I am in the loop k only, right? So when k is incremented now, so when k is equal to 0, I took the element first 0th row 0th column element of matrix A, multiplied with the 0th row 0th column element of matrix B, and I am storing the result as 10 there. So now when k becomes 1 here, when k becomes 1, the loop again the k loop runs here, and here what happens is c of ij, c of 0, 0 is equal, means the same data c of 0, 0 is getting updated there. C of 0, 0 value plus a of I1, b of 1 j. The j value is j value and I values are 0 there. So here what will happen is a of 0, 1 into b of 1, 0, means this is a of 0, 1 into b of 1, 0. So this is going to be computed. That is a of 0th row first column is this particular element multiplied with the b of 1, 0. So this is the element. So 1 and 2 gets multiplied. So what I get here is 1 into 2 is 2. We get the value as 12 as the value of c of 0, 0. Still we are in the k loop only. K further incremented, k becomes 2 there. When k becomes 2 there, so what happens is again the loop will run. So when k becomes 2, what we compute is, so a of 0, 2 multiply with b of 2, 0. So that is, so I take the element 3 and we multiply with the next element. That is, this is the value of a of 0, 2. A of 0, 2 means 0th row second column, and b of 2, 0 means, so second row 0th column, right? So this is the value 3. So 3 into 3, 9 I get. 9 I am going to add this. So what I get this, something like 21. 12 plus 9. So then again still I am in the k loop here. So when k becomes 3 there, so I will be taking 0th row third column element. So here it will be 3 and here it will be 3, 0. So 0th row third column is this particular element, and third row 0th column is this particular element here. So 1 into 1. So to this I will add up 1. I will get the value as 2. So now when k becomes 4 there, so 4 is not lesser than the 4, I will be coming out of the k loop. So you just look at the code here. When once I comes out of the k loop here, so I computed the value of c of 0, 0. So I go for j is equal to incrementation of the j becomes 1 there, I will be computing c of 0, 1 in the next iteration. But so far what's the value of c of 0, 0 we computed? 22 here. So 22 will be the value corresponding to the 0th row, 0th column element of the resultant matrix what I get here, right. So here when I take the products here, 2 into 5, 1 into 2 plus 3 into 3 plus 1 into 1, we will be getting the value as 22 that will be stored in the resultant matrix. So this way when I proceed, so k number of times multiplication, so I store the result in the resultant matrix C of 5. This particular code segment is the logic of multiplying the two matrices of a two matrices. Here only condition is like the number of columns of the first matrix should be same as the number of rows of the B matrix, and the order of the resultant matrix what we get is M cross Q, where M is number of rows of the first matrix and Q is number of columns of the B matrix. This is most important here. So n should be equal to p, number of columns of matrix A should be same as number of rows of matrix B. Now, so this is the lab program what we have. So that is develop, implement and execute a C program that treats two matrices A of M cross n and B of order P cross Q and compute the product of matrices A and B. Read matrix A and matrix B in row major order and in the column major order respectively. Print both the input matrices and the result matrix with the suitable headings, and output should be in matrix format only. So this was recommended whenever you are printing the matrix, the output should be in the matrix format only. So program must check the compatibility of orders of the matrices for multiplication. So report appropriate message in case of incompatibility. Incompatibility means if the number of columns of matrix A is not equal to the number of rows of the matrix B, then we cannot perform the multiplication there. Now, so before we go for the multiplication of two matrices, let's revisit the row major ordering. In case of row major order, what we do is we read the elements of the matrix row wise, right. So here 11, 21, 34 as the elements. So since we are mentioning here 2 rows and 3 columns, so in each row we have 3 columns. So 11, 21 and 34 are the elements of the first row, and 14, 55, 62 are the elements of the second row. So here is the result. So 11, 21, 34 is the elements of the 0th row, and 14, 55, 62 are the elements of the first row. So is the reason here the elements are like 11, 21, 34, 14, 55 and 62. So in the row major order, the consecutive elements of the rows of the array are in the continuous memory location. Row wise the elements will be get stored there. So now, so the column major, in case of column major, so this basically the column major ordering is not supported in C. The C supports the row major ordering. In certain languages like Fortran, the column major may be used. So now in the column major ordering, so what we do here is 2 rows and 3 columns, we read the element column wise. That is, since we have here, so 2 rows and 3 columns, so 11 and 21 are the elements of the first column, so 34, 14 are the elements of the second column, 55, 62 are the elements of the third column. So is the reason. So here we may feel like the elements are arranged in a shuffled manner. So it is not in the order as we seen so far, because C supports the row major ordering. So is the reason after A of 0, 0 we have taken it as A of 0, 1, 0th row first column. But here in case of column major, the index will be like A of 1, 0 and then A of 0, 1. So then A of 1, 1 is 1, 1. You can see like the column index is same here, 0th column, 0th column. Here also you can say like first column, here second column, second column. Only thing is row is changing. The reason is this is a column major ordering. So here the matrix will be like 11, 21, 34, 14, 55, 62. This happens because the consecutive elements of the columns of the array are in a continuous memory. In this particular column major ordering, the column wise the elements will be get stored over there. Now, so this is the program to read the elements of the matrix in a row major order. The normal matrix so far what he computed, it's all a row major ordering, because the C supports row major ordering. So we have to read the elements in row major order. Now say for example in this particular code I am declaring A as an array of 10 cross 10, right. So since I am declaring an array of 10 cross 10, I am not initialized the array with any value. So the junk value will be there in the allocated memory. So you can see like some data is there, 2, 3, 4, 5, 6 or 3, 4, 4, 5, 3. All these are the junk data that is present over there. Fine. This is neither partially initialized. If you are partially initializing the array matrix A here, that is 2-dimensional array A here, then all values could be 0 here. But since I am not initializing it, so locally I have declared the 2-dimensional array of 10 cross 10 matrix here. So here, so what happens is all the element values will be of some junk data. The first element is A of 0, 0. Last element will be 9th row and the 9th column element. Here assume, so I am entering the row and column order of the elements size of the matrix, that is order of the matrix. M is 2 and n is 3. How exactly I read the elements into the row major ordering? Now, when I is equal to 0, j is equal to 0, if I am assume I am entering the value 22, the 22 gets stored so in the A of 0 0 location. Now, so when I go for when I is equal to 0, j is equal to 1, if I am entering 7, that will be taken in its proper position, 0 through and first column. Similarly, when j becomes 2 there, I am running in the j loop here. When j becomes 2, 0 through second column element I will be reading. So, the value gets located in this particular memory area. Since I am mentioning here like number of rows is 2 and number of columns is 3. So, the three elements of the first row has been read here. That is from the program point of view, 0 through 0th column element is 22, 0 through first column is 7, 0 through second column element is 4. Similarly, in the next iteration of the j loop, the j becomes 3. So, because when j becomes 3, we have only the 3 columns and all the 3 columns have been read. So, we are the condition j less than n fails. So, we go out of the j loop. When we go out of the j loop, the I value gets incremented there. When I value get incremented, I becomes 1 there. When I becomes 1, again the j becomes 0. If I am entering the value 84, in the first row and 0th column, 84 will get stored there. So, again when j is incremented, the value 5 is get stored, and if I am entering 15, the 15 will get stored there. The rest of the elements I am not using here. So, you see now when j becomes 3 now, so again the condition fails, I will be going out of the j loop. In the next iteration, the I becomes 2. Again go out of the I loop, because number of rows I have mentioned here as 2. So, 0 and 1. So, 0 through and the first row. So, I need to go out of the I loop also. So, we can see like here I am using only the 2 into 3, because order is 2 cross 3 here, 6 valid locations. Remaining locations of the allocated memory space I will not be using. So, their data will remain as the junk data. I call this as a junk data because this data, whatever it is stored from A of something like in this location up to A of 99. So, these particular data is irrelevant to our program. So, I call this as a junk data or the garbage data. So, only the valid data is 22, 7, 4, 84, 5, 13. So, here this is a 0th row element, this is the first row element. So, this is the way how exactly I read the matrix and in a row major order. So, while printing the matrix, it is quite common in the same manner we are going to print the elements. The percentage d elements of matrix are like I is equal to 0, I less than m. So, I j is equal to 0, j less than n, I will be printing the elements of matrix A. Now, so the simple output of this particular code is like I take the size of the matrix as 2 cross 3. If I am taking the same elements 22, 7, 4, 84, 5, 13, so they are printed in the row order. So, 22, 7, 4 are row elements, first 0th row elements, 84, 5, 13 are first row elements. Similarly, if you look at the column major elements, so here this code is quite different. When you are reading the column major value, since C supports the row major, so we have to read the data in the column major. Reading the data in the column major means first I should read all the column elements, 0th column, then I have to go for the first column, then I have to go for the second column and so on. If I take m is equal to 2 and n is equal to 3, we have 3 columns here. So, I should take the data of 0th column, elements of 0th column, then elements of first column, then elements of the second column. So, is the I loop. When I is equal to 0, so this I specifies the column. When I is equal to 0, I will be reading the elements of the 0th column. When I is equal to 1, I read the elements of the first column. When I is equal to 2, I read the elements of the second column. Similarly, when I is equal to 0, j is equal to 0, in the first column, 0th column, I will be reading 0th row element. When j becomes 1, keeping I is equal to 0, in the 0th column, I will be reading first row elements. We will see in this particular example now. Assume initially when I is equal to 0, j will be 0 there. When j is 0, I is 0, I am reading the value for A of 0, 0. See here the index, it is not A of ij, which we commonly use for reading the elements row wise. How basically the C supports, since we have a practice of using the C construct, so that is it's arrange the elements in row major ordering. So, we use here ij, A of ij, but here since I have to read the element in column major, it has to be like A of ji. So, where I should be less than n, here j should be less than m. So, normally what we use is in the previous code of reading elements of matrix in row major, we check the condition here as I less than m, and here the condition as j less than n, and here we take it as A of ij. But here since we have to read the elements in column major, so is the changes what is supposed to do. The one which is in blue colored, so the statement, they are the modifications what is to be done with respect to the row major ordering. So, now when I is equal to 0, j is equal to 0, A of j0 is A of 0, 0. I read this particular element. So in the 0th row, 0th column, this is the value. So next element of the same column is first row and 0th column, right? So when in the next iteration, when j becomes 1, so we see that the 7 value we get in a of 1 0. We do not get in a consecutive locations, but we get in a of 1 0. So first row and the 0th column. So here when you take this particular element, so we get the value there. When again when j becomes 2 there, so number of rows we have is only 2, so we run out of the j loop. So then, so when I becomes 1, we read the elements of the first column. So when I is 1, j is 0, we will be reading 0th row and first column. So this the first column element we are going to read, and the first element of the first column. Then when j is incremented, we see the second element of the first column, right? So similarly, when now the j becomes 2, I will be coming out of the j loop, and similarly when I becomes 2, I will be reading the elements of the third column, that is when I is equal to 2, third column, because we have 3 columns there. So we read the element when j is equal to 1, we see the second element of the third column. Again when j becomes 2, I run out of the j loop. Again when I is incremented, I becomes 2 there, so I will be coming out of the I loop also, right? So I value will run from 0 to n. So here what happens is, n is what? Number of 3. So in this particular case, so this value should be 4. So see, in the previous case the I value was 3, after incrementation it has to become 4 over there basically. So when it is 4, I will be coming out of the I loop. So then I will be reading the elements here column wise, though it is ordered in the form of a in the C it is stored in a continuous memory area, but I am reading here in the column major, fine. But the C stated that internally it is stored in the row order only, but I have read the elements in column order. So while printing will be same as usual, there is no change in that. Now if you look at the simple output of this, so I am mentioning here 2 cross 3 as the order of the matrix. The 6 elements of the matrix I am mentioning here as 22, 7, 4, 84, 5, 13. So this is I am entering the elements in column wise. Since we have 3 columns, 22 and 7 are the elements of the first column, 4 and 84 are elements of the second column, and 5 and 13 are the elements of the third column, right? So is the reason we have like this. So but if it is row major, 22, 7, 4 will be the elements of the 0th row, but here we don't have 22, 7, 4, rather we have 24, 22, 4 and 5, because we are read the element in a column major order. So in column major order, we must input the elements column wise only. So is the reason we are getting in this particular way. So when you come to the algorithm here, we have to read the order of matrix A to perform the matrix multiplication. When you are reading the performing the multiplication of 2 matrices, first you have to read the order of matrix A, m cross n. Then you have to read the order of matrix B, p cross q. Then you have to check whether n is equal to p or not. If it is not equal to p, you have to print a message: incompatible matrix order, multiplication not possible. So otherwise multiplication is possible. We are coming to the next statement here. So here in this particular case, you have to read the elements of matrix A. So I is equal to 1 to m, j is equal to 1 to n. You have to read the elements of matrix A. Next, in continuation, in this particular statement, you have to see that you have to read the elements of matrix B. In the program, it is given in the lab exercise that you have to read the elements of matrix B in the column major. So is the reason I is equal to 1 to q. It is not I to p, 1 to p. P is the number of rows of the matrix B. So we have to read from I is equal to 1 to q, j is equal to 1 to p, read element of matrix B, B of ji. I am not using here B of ij, rather I am using here B of ji, because I have to read the elements in a column major order. After that, I do the multiplication. We have seen the logic of that. So I is equal to 1 to m, j is equal to 1 to q, c of ij is 0, k is equal to 1 to n. I perform this particular addition and I am storing the result in C of ij. This initialization is must. C of ij initially we have to conclude it as 0. After computing each product, we have to take the summation and you have to store the result in resultant matrix. It's fine. So I'll end up here. In the next session, we will see the conversion, transforming this particular algorithm into a program, right? So this is finally supposed to print the output of the product matrix. So for I is equal to 1 to m, j is equal to 1 to q, elements of matrix is so on. So you are going to print that. We see the program to compute the product of 2 matrices. How to transform this particular algorithm into a C programming statement, we'll see in the next session. So thank you.